Modern World History students. This is Sanchez with part one of our first installments of our Age of Enlightenment flip lectures. And today we're going to focus on part one of the flip lecture series, which is looking at something called the Scientific Revolution. Quick recap from our discussion in class. Remember, we're beginning to discuss the concept of revolution. So we talked about the word revolution usually means dramatic change. It's not just isolated looking at a revolution meaning war. A lot of students come in, okay, revolution means there's a war of some sort. Not necessarily the case. We can also talk about revolution of ideas. So in class, we kind of touched on briefly with our discussion, some on the screen right now, why things like democracy, or maybe more currently, things like social media, why you could argue, again, these developments were revolutionary, meaning they're going to change our perspective, the way we understand the world, the way we participate in the world. So we're trying to make the comparison between how ideas of the Enlightenment are dramatically going to shift the course of our future discussions of human history. Now, when we talk about the Enlightenment in class, we talked about it's roughly in the 1700s, so this is an 18th century period. And we also are going to talk about in terms of how the Enlightenment is going to have four main aspects. So today, the first bullet we're going to kind of touch upon is the concept of scientific thinking. So looking at the scientific revolution, and again, the word revolution right here, so the changing the way we're thinking about sciences in general. We're going to talk about how that lends itself to the social sciences. In class, we're also going to talk about how the Enlightenment is going to help us understand the political. So looking at the role of government, and definitely at this point, we've definitely introduced the concept of government. When you think of government right now, you should think about who's controlling society, who's in power, who's making the rules, the system in place, whether that's a monarch, whether that's a dictator, whether that's a church, or again, most of our discussion was based on democracy. We're going to look at social and philosophical beliefs. So what is asking questions about the course of human nature. Are humans good? Are humans bad? Should they be checked? Should they be monitored? Should they be trusted? Should they be given rights? Are rights earned, or are they God-given? So kind of some deep philosophical questions in this unit. And then finally, at the end of the unit, we'll be looking at the Enlightenment influence on arts, music, and literature. All right, and then before we dive in as well, I want to take a look at our essential questions, or in class I refer to them as the driving questions. Don't necessarily have to write these down word for word, but just want to make sure that before we start taking notes that we're mindful of what we're trying to understand. So we're still trying to figure out what the period of the Enlightenment, what it was all about, and ultimately what were some of the main ideas of the Enlightenment. The second question I posed is a little more open-ended. So it says, how do new ideas spark change and revolution? Okay, so oftentimes these new ideas, they kind of start sort of that domino effect, one idea, and then it spreads, and then it spreads further. So how do we see that process, this evolution begin to happen in 1700s? And then finally kind of focus specifically on this flip lecture, how do scientific discoveries lead to new ways of thinking about the world? All right, first things first, if we're going to talk about the scientific revolution, remember talking about change, we need to refresh our memory a little bit about what happens before. So change means something was one way, and again, we see a shift or a transition. So on the screen right now, the question I pose is, what developments were the foundation of the scientific revolution? So on the left side of the screen, you're going to see a connection to our discussion of the Greeks and Romans. Now, you studied the Greeks and Romans previously, and we know all their contributions to drama and architecture, and of course we looked at their contributions of government. But the Greeks also made contributions to the sciences, to astronomy, to mathematics. And unfortunately, when the Greek civilization fell, and when we see Europe sort of transition into that period of the Dark Ages or the Middle Ages, a lot of that knowledge was lost. And primarily one of the reasons why it was lost in the language, because Latin was the language that was used by the Greeks and Romans at the time. Now, in your 7th grade world history class, you talked about a period that comes later, so right around again in about the 1500s, but you talk about the period known as the Renaissance. Now, the Renaissance is going to be a period where Europeans are going to begin looking at sort of rediscovering the works of ancient mathematicians and astronomers And the Renaissance thinkers believed that mathematics were the key to understanding the nature and how the world works. Now, previously, the way that was believed before, the way the world works, was really based on the beliefs of the church. A lot of the beliefs that were commonly used during the Middle Ages was developed based on, again, the church's teachings, and looking at Earth as the center of the universe, and of course, in relationship to God and the heavens and what have you. So if we're talking about the scientific revolution, we're talking about scientists begin rejecting the old teachings. Rejecting the old teachings, kind of going back to the roots and trying to ask new questions. They're trying to approach new ways of thinking about the world. And they're trying to use concepts, talking about your science class. I'm sure you guys do experiments. You guys are making observations. You're asking questions. And the two key words that we introduced in class as well, when you think about the scientific revolution, and these words also pop up when we talk about the Enlightenment, is again using logic and reason to guide your thinking. The universe is not so mysterious. The universe is not necessarily superstitious or magical, or again, these things do not happen in random. If we use observation, if we use our critical thinking, if we use our mathematics and what have you, we're going to begin to recognize patterns, and those patterns can help us better understanding nature and the physical world. So during the Middle Ages, most scholars, most people believed that the Earth was an immovable object located in the center of the universe. They thought pretty much the Earth was right smack in the center, and everything else sort of circulated or moved around it. So according to this belief, the moon, the sun, and the planets all moved in perfect, like almost round circles and paths, orbits around the Earth. Now, when you think about it, at the time, observation from their perspective, common sense kind of supported the view. I mean, after all, the sun appeared to be moving around the Earth as it rose in the morning and set in the evening. So this was called geocentric theory, okay, this Earth-centered view of the universe. And this idea came from Aristotle, the Greek philosopher, and then later on we have Greek astronomers that built onto this. But besides that, Christianity also taught that God had deliberately placed the Earth in the center of the universe. And Earth was, therefore, it was a special place, and kind of everything kind of worked around there. So you have old ideas from the Greeks, again, based on the limited knowledge they have. You also have the ideas of the church, sort of corroborating and kind of saying, yes, this is true, Earth at the center. And then, of course, out in the periphery, you have heaven, and of course, you'd have God out in the distance. So this would be the old school belief of geocentric theory. All right, so moving forward, if that geocentric theory was one belief, we're going to see later on in the 1500s, one scientist by the name of Copernicus, he is one of our early scientific thinkers, and he's going to believe, using mathematics, that he believed in something called heliocentric, or in this case, sun-centered concept, that the universe, it offered a more accurate explanation. So in this system, the sun, not the Earth, was actually, in his perspective, the center of the universe. And the planets revolved around the sun. The moon, however, revolved around the Earth. And pretty much according to Copernicus, the apparent movement of the sun around the Earth was caused by the rotation of Earth on its axis and its journey around the sun. All right, so here's a good time underneath your notes. Let's go ahead and create a little chart for our note-taking purposes. So at the top, we'll create 3 columns and make it nice and big so you can write and give yourself some space. So we're going to write at the top, scientist, discovery, and impact. So if we're reviewing one of our first scientific thinkers, we'll write down the name Copernicus. Now his discovery, the one that he develops or adds on to the scientific revolution, is the concept that the Earth is not the center of the universe. It's actually the sun is the center, and Earth is going to revolve around that. Now I put right there the impact. So the impact or the importance of this is the universe is based on observation. So again, Copernicus using observation, scientific thinking, reasoning, hypothesis, mathematics, all of these combined are going to be challenging these new ideas and their perspectives. Now, scientists could think in terms of how the planets revolved around the sun, and looking at, again, their orbits. But an important question kind of remained unanswered at the time, and it was the question of what planets, what are they made of? And how does one explain motion in the universe? So we have on the screen right now, I want you to write down the scientist Galileo. Now, Galileo, in this case, he was a scientist, and he began to hypothesize that the perspective that a lot of the heavenly bodies out there that a lot of scientists or astronomers observed, they at first thought that they were just light, kind of far off in the distance. And Galileo began sort of adding on to the fact that no, actually they're made of matter, looking at things like Earth in this case. So when Galileo published some of his books, for example, he announced that Jupiter, when he was making observations, had 4 moons, and the sun had actually dark spots. And he also noticed that the Earth's moon, he made observations that actually was rough and had an uneven surface. So again, this goes back to that perspective that the Greeks, like Aristotle and the church, they had previously said that, you know, the moon and the stars, they were made of perfect substances. They were more just like bodies of light out in the distance. Again, besides of using this observation, one of the things we see is Galileo definitely got criticized, got challenged, got persecuted in the fact that the Catholic Church did not agree with this perspective. Remember, challenging the church was a pretty bold move in this time, since so many people were very divert to their faith. All right, the last two and the third one on your list you'll probably recognize. We also could talk about a scientist by the name of Isaac Newton. Now, Isaac Newton was the scientist that came up with or sort of developed the ideas of the laws of gravity. And this also sort of added on to, again, looking at astronomy to understand, again, what is the connection between, again, the Earth and sort of the gravitational pull and how we necessarily see those objects rotating. Now, I put up there as well as the impact, besides the fact that this is adding to, you know, the law of gravity, physical laws, laws of motion in this case. It also recognized the fact that we begin seeing that humans can understand the universe through these natural laws. So again, the famous story is the apple. Okay, Isaac Newton was sitting under their tree, an apple falls on his head. Okay, you ask the question, why did the apple fall? It's not just a magical thing that happens, that it just floats down. Again, we're looking at a gravitational pull that brings that down to the Earth's surface. And the last one that I placed on your list, just to introduce, because we want to be mindful if we're talking about history, we don't want to miss out on her story. Okay. The last one that I put is Cavendish. Okay, she was also a scientist at the time, and she also wrote quite often of looking at her scientific discoveries, and that her perspective was that humans were the master of nature. And again, going back to the belief that the scientific revolution was trying to, again, ask questions, use reason, make observations, recognize patterns, and break away from the old traditional teachings of the church. All right, the revolution in scientific thinking that Copernicus and Galileo and these other scientists begin eventually developed into a new approach in science that's referred to as the scientific method. And the scientific method is kind of the logical procedure, like the steps for gathering and testing ideas. It begins with a problem or a question arising from observation, and then scientists form a hypothesis. Hypothesis is tested, the experiments, analyze data. So this is the kind of, you know, traditional scientific method approach that was introduced. Now, of course, I got to connect to what you are learning about in your current science classes, because I know in classes right now you're also looking at principles of the nature of science. So a good example of this connection, one of your principles is science is tentative, right? It is changing, it's developing. So case in point, if we're looking at geocentric theory versus heliocentric theory, it's something necessarily to kind of tie to our discussion of the scientific revolution.